All right, you guys, so let's look at that last identity problem. Again, I know that the XYR definition is going to probably be so much easier to use here. However, we're trying to learn the identity, so it's always tough to try to wheel students back because we all agree that XYR definition is easy, but we're trying to learn the identities, and the only way you're going to learn how to use the identities is to use the identities. So let's go ahead, and even though we know there's an easier way to do a problem, how about you can use that to check your work, right? Especially with your homework or what I'm doing here. But let's go ahead and use our trig identities to do the problem. So for starters, we know that the secant is 9/5. It's positive. And we're told that the tangent is negative. So that tells us secant is positive in quad number 1 and quad number 4. And the tangent is negative in quad number 2 and quad number 4. So this basically tells us, if we put those two together, that our angle is in quad 4. So our x is positive, our y is negative, and that's positive. So if we were using XYR definitions, but we're not. So what trig identities do we use? Well, the easiest one is probably to use the fact that we know that cosine is 1/secant. So that basically tells us what cosine is right away. Cosine is going to be 5/9. So that one, pretty easy to find given the information. Right? So what's next? I would recommend you find sine, because once we have sine and cosine, we pretty much have everybody else. So how do we find the cosine? Well, the one that relates sine to cosine is our Pythagorean identity. Cosine squared plus sine squared is equal to 1. So subbing what we know about cosine, we can solve this for sine. I believe this will be 25/81, right, plus the sine squared of theta equals 1. Subtracting that, we essentially get that the sine squared of theta is 1 minus 25/81. That's 81/81. And so what do we get there? I know for sure we got 81. 81 take away, let me do that. Borrow that, that's a 6. 56? I think I did that right. Alright, so 56. And so taking a square root, we have the sine of theta is plus or minus the square root of 56 over the square root of 81. We know the bottom is 9. We know we're expecting a negative because we're in quad number 4. And I think 56, to simplify that, I think that breaks down 8 and 7. Yeah, that's 4 times 14, I believe. So we're looking at 2 square roots of 14. So there's finally our sine value. Yes, I know the XYR definition's faster, but we're using a trig identity and using some good algebra skills. So there's our sine. So now that we have sine and cosine, we pretty much have everybody else. So, oh, by the way, since I have sine, right, how about we use the fact that the cosecant of theta is 1 over the sine of theta, right? That might be the fastest one to do. Well, doing a reciprocal, we get negative 9 over 2 square roots of 14. Rationalizing that, we get negative 9 square root of 14. I think we'll get 28 down there on the bottom. So there's our cosecant of theta. So far, so good. We have 3 of them. 2 more. Tangent might be the easiest one to find next, because we know that the tangent of theta is sine over cosine. And we just found out the sine, that's negative 2 square roots of 14 all over 9. And we know that cosine is 5/9. So multiplying by a reciprocal, 9's cancel out, and we find out that the tangent of theta is negative 2, that's a 14, square roots of 14 all over 5. So there's our tangent. And then once we have tangent, we know that the cotangent is 1 over the tangent. So finding that reciprocal, we have negative 5 over 2 square roots of 14. Again, rationalizing my denominator, we get negative 5 square roots of 14 all over 28. So there's our cotangent to theta. So there's our other 5 trig values using identities, right? So we begin with secant is 9 over 5. That naturally gave us cosine. We can use the Pythagorean identity, relate sine to cosine, and get the sine value. Once I have sine, I have cosecant. And then once I have sine and cosine, I have tangent. Once I have tangent, I have its reciprocal. So I agree, that's a lot more work than our XYR definitions, but we're learning how to use the identities, and we used, how many? It looks like we used 3 different reciprocal identities. We used a Pythagorean identity, and we used a quotient identity. So you use them, you get better at them. So that's why we're going to be doing this like crazy throughout this week. Okay? So there you have it. There's our old idea of basically finding exact trig values. Something we've done before. All right, and we're just reiterating yet again, maybe kind of honing our skills a little bit and getting better at it. All right, more things later, simplifying expressions, rewriting them. That's pretty much what the rest of this chapter is and what the future videos are going to show in a moment.